talk a lot about statistical process control being a wonderful thing within Lean Six Sigma, but when do you actually use it and why? Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video is going to be about statistical process control, but not so much about how to do it. I mean, there's quite a lot of content on how to perform SPC. I've done a couple of videos on them as well. But one of you asked me, so when do you actually use SPC? For which processes or things is it useful? And of course, that's a brilliant question, because let's not put anything into place where it is not useful. That might be the biggest waste of all. And within Lean Six Sigma, we are fighting wastes after all. So the statistical process control, we do go over a little bit of how it works, because that makes it a lot easier to explain when and what it is for. What we have is that we have a process that we monitor. The mean of that process, so we are measuring one thing in a process, which can, for instance, be the weight of some product coming out of our machine. And from history, we know that there is a certain average weight that comes out of this process. And we also know that if we take plenty of historical data, that there is a sort of a natural spread. And this natural spread we express in standard deviations. And these lines, the upper and lower control limit, they are 3 standard deviations higher than the average and 3 standard deviations lower than the average. And then when we go and check, there are some middle lines on 1 and 2 standard deviations as well. But at some point we see, hey, something is going wrong here. This point by itself would also indicate something went wrong, but here already we see there's too many points outside of our secondary control limits. But what does that mean? It doesn't mean that we went over specs, because specifications don't really have anything to do with statistical process control. Now, of course, a smart company will check that we at least have processes that run within specs. But this tool by itself, no specifications in there. So maybe we're still on specifications. This tells us that our process, which is basically this mean with roughly this one standard deviation, this process has moved. There has been a shift downwards. So something is now going quite differently than it used to be going for this process. So again, we don't know whether we were making or breaking specifications purely based on statistical process control. We know that our process is behaving differently than we are used to. So we have lots of historical data. We know that even if you have a process that you think has a very big spread and you're not very happy with it, still the way you set up statistical process control is then, well, these control limits become very wide, maybe too wide for your liking, but they become wide because these control limits are the 3 sigmas based on the historical data of this process. So when it goes a certain way, you know that there was a shift in how the process is behaving. And that is what we do with statistical process control. We check, is our process statistically significantly differing from what we were used to? Now, that will give us most of the clues we need to also discuss when do you use this tool, at what parts of a process, why would you use it on some parts, not on other parts. And the first thing is already, it is about process control. So let's start with that. It is always in a process. So when we have our process, the process itself, it has a number of inputs and a number of outputs. The outputs are often one product, so to say, and even the input may be a number of inputs is one product, but here you should see it in a way of the product has a weight, a color, a temperature. So there are specific characteristics of the product, and these are all outputs. And the inputs are your materials coming in, but also the machine settings, the temperature of the machine that is doing the process, things like that. So this is what is making the process to your ingredients. Now what we are trying to see is whether the process, so this thing, is performing or behaving as it should be. Now the best way to test this is of course to take some of the outputs and put them under the magnifying glass. We are going to check, are our products coming out, are they all of the same size, or at least is the size not different than what we would expect based on what this process was always producing. Because as I said, it can be that you have quite a big spread, but at least it should be more or less centered around the mean and also not go over the historical spread. So that is always a very good place. When you want to check, is my process behaving like I expected? And well, at least is it behaving as stably as I know it should? You check one or more of these outputs. And basically you can check any output that, that will give you a good idea of how stable your process is. So it depends of course on what you're producing. But if you're producing products that have indeed a weight that is important, please, a weight. Or maybe you are making things where you want exactly 50 pills in a bottle, or it can be between 48 and 52, but not 60 or 30, because then we're getting into problems, and counting them is easier than weighing them. It's basically the same thing, right? So how much is my machine making? It can also be the outgoing temperature. It can be things like the number of holes. This actually, for a cheese factory, it might sound funny, but is a quite important indicator for specific types of cheese. If you have a Maasdam or an Emmental type of cheese, you expect there to be big holes. And we actually did do these type of tests on the number of big holes and the number of small holes in a cheese, and that is surprisingly difficult to count. So we even had, well, it was easy equipment, but still special hole meters, so to say, to count the number of holes. Things like that, so quality parameters, weight parameters, production parameters are very good to do a statistical process control on. What is not really a good thing to put statistical process control as an output is the amount of production, and then specifically in, let's say, a line speed. So we have OEE, overall equipment effectiveness, measurements for that, and they are much more suited to that task. Statistical process control on, is my machine running well? It will not tell you a lot. This is about the stability of the process itself. Now, you can also check some of the inputs. They are a bit less important maybe, but they can be, for some processes, they can actually be very good leading indicators. And this is also one of the things you're doing with SPC. It is never actually real time. You're always checking afterwards what was happening, but you are trying to catch a problem before it becomes too big. You are trying to detect deviations, preferably before they make your product go over specification limits. Now, if we have the inputs, there might be, for instance, an input which is your temperature. If you are heating or sealing something, these are very nice things to be watching for. And it depends a bit on your process. If you have a process that takes heat out of your heating plates, you do need to know what point in my process cycle will I measure, so that you don't introduce too much spread in your measurement. But for instance, if you always measure the temperature of your sealing plate just before it gets pressed as a contact to seal your plastics, your packaging, that would be a very nice thing to see that the plate gets back to temperature on time before the next cycle, that the temperature is correct. And it might, for instance, be that, especially when you are sealing these plastic packagings, that a little bit of the plastic settles on your sealing plate, it doesn't heat up as nicely, it doesn't deliver the temperature as nicely. And by this, you are deteriorating your process and can get into quality problems, basically. So then, that would be a very nice thing to watch out for. One very nice example of this is the in and outgoing temperature, for instance, in pasteurizers. So you have an inflow temperature, then it should heat up. You have an outflow temperature, and in this heat exchanger, you are heating up the product. Now, the water that you put in as the heating side of the temperature exchanger, that mainly, well, usually has the same temperature. It's quite often even steam that you're pushing in. But if there is sediment on the plates, so if there is calcium or other stone on the plates, it gets dirty. Or on the product side, some of the product has made a film on your heat exchanger plates, the heat transfer will not be as good. And you will see that the delta of the temperatures going in and out, it changes, it becomes less. And this is a very nice thing to use for predictive maintenance. So you basically follow temperature, you know that when you have a clean machine, it always stays within this. And at some point you see, oh, it's not transferring enough temperature anymore, and you can do something about it. This is not very pure statistical process control because you really know that it will happen. So it's more like a process control chart where you're just waiting for a specific limit to be reached, but you use the same calculations, the same way of setting it up. When it does work brilliantly is when you're sort of testing an input and an output at the same time. Because you will see this, especially in factories, where you have a number of processing steps, and this is quite common. I mean, our manufacturing lines often have a number of steps in them, and sometimes with quite some time in between. So if we know that from one process we are making a semi-finished product going into another process, and that is making our final goods, then these ones suddenly become very valuable as well, especially if there is some time in between. So again, do check your real outcome, and then specifically the parts of the outcome that are the best indicator of how stable the process is. But these ones are important inputs for your second process, and they are outputs of your first. It's likely that you don't have very strong specification limits for these, that you may be able to correct things. So when the weight is a bit lower, then maybe during storage it will attract some moisture, or here with the first check weigher, you know to set the machine a bit differently and slice 9 parts out of it instead of 10, and then again your end slice product has correct weights, things like that. So we very often correct our own internal products, but these are golden to also put your statistical process control on. Make sure that this process is performing as it should be, and you know what this process is doing, and you know what your follow-up process would like to have as a best product coming in, and that is stability. Because that's the thing, your customers like stability, but more than that, your customers, especially if you are talking about really customers like a food company or a pharma company has, where your customer is also really the user of any product, then it just has to be within expectations, within specifications. But for a next processing step, the best you can have is stability, is very, very strong stability, because almost any process can be tweaked to handle most types of material coming in, as long as you know it before, and that you can optimize the next process to play exactly correct with the intermediate products coming in. So for those, you need to control the processes, not keep them roughly within specs that would be okay on the market, but try to keep it as close to whatever ideal norm, or in fact as close to itself as possible. That is a brilliant part to do SPC. So when we check when in our processes, in our operation, we do SPC, it is to check if our process is deviating. It has nothing to do with the specifications yet, of course, because somewhere here we also know that there are specification limits. When our process deviates too much, we will run over a specification somewhere. This is a leading KPI for specification breaking, and it's a lagging KPI for what the process is actually doing. We are checking our processes. And for that, we can check inputs. We can definitely check outputs. With the inputs, don't check some purchased materials so much. That's not very interesting. Check things like what are the temperature and the pressure settings that I put in, what is happening with process parameters. For outputs, check anything that is a quality parameter of your product. Don't check how quick your machine was, how many products were made. That is not something you want to statistically control. That's just, money and really a resulting KPI. But do check things like what's the size coming out, or do things fit in each other? What do we see in a sort of a minor defect maybe? So all kinds of quality-like parameters of your intermediate products, very nice, and final products. And you do this to make sure that your systems are doing what you expect them to be doing. Now, I know to really give a clear answer to when to use it, I basically have to go to your factory, have a discussion with you. What is happening? Where are your critical points in the line? Which parts of it would you really like to check? Because if you're going to do SPC on all the parameters, you're going to overwhelm yourself and your operators. But still, I hope that this discussion and what it is for, what it is not for, gave you some good grounds to think about where in your organization should SPC be used, where can it contribute to making the process better. And if you did, of course, don't forget to hit that like button. For now, I wish you the best of luck stabilizing and improving your processes, and as always, enjoy the improvement journey.